Okay, so now we move on to finding and interpreting the average rate of change. And notice the equation that they give you is something similar to what I gave you. I said it's f of x2 minus f of x1 all over x2 minus x1 because we are using the x values to plug in there. And I don't like to get confused with b and a because b and a have nothing to do with ax squared plus bx plus c. So it can get really confusing when you're looking about that. So again, this is what we have for our equation here, f of x2 minus f of x1 divided by x2 minus x1. Okay. So finding the average rate of change from an equation. So there's different ways that we can find it. We can find it from an equation. We can find it from the graph. We can find it from a table. If we're finding it from here, which is negative 3 to 3, so when they say over the interval, notice this is not a point. It would have parentheses around it if it was a point. These are two x values. So it says find it over the interval when x is equal to negative 3 up to when x is equal to positive 3. So 3x squared minus 8x plus 2. 3x squared minus 8x plus 2. So there's my function. And we are trying to figure out over the interval of negative 3 to positive 3. And that, again, is dealing with the x values. So we are going to calculate those. So we are going to figure out what f of negative 3 is by plugging it in. 3 times negative 3 squared minus 8 times negative 3. Always use parentheses as much as possible. That is 9 times 3, which is 27, plus 24 plus 2. That is 29 plus 24, which is 53. Okay. So we have that particular number. F of 3 is 3 times 3 squared minus 8 times 3 plus 2. That is 27 again, minus 24 this time, plus 2. That is 3 plus 2, which is 5. Okay, so then the average rate of change is what we're trying to calculate here. So we want to figure out what that average, I wanted to see if they called it anything, just to point it out if they did. So we want average rate of change equals, so we do f of 3 minus f of negative 3, right? Because we do the larger value first, so f of 3 minus f of negative 3. So it's going to be 5 minus 53 all over the larger number minus the smaller number. So we have 5 minus 53, which is negative 48, all over, in this case, notice that's 3 plus 3. So that is negative 6 goes into 48. I don't know why I'm not thinking this, 8 times. So that would be 8 times, negative 8 times. So that would be negative 8 here. So if we do a drop down, we can check and see if we're okay. Okay, let's move on to the next one. So now finding it from a table, table's a little easier because I don't have to plug it in. So if I'm finding it from an equation, I have to plug it in. But here we have a table. Notice here's our x values again. Negative 2, positive 4, negative 2, positive 4. So our f of negative 2 is negative 9. F of 4 is 3. So negative 9. So we're going to do 3. So always the larger number. 3 minus a minus 9. So we're going to do our another average rate of change. So it is 3 minus a negative 9 all over. So those are the y values. 3 minus that one, 4 minus that one. So 4 minus a negative 2. So that is 3 plus 9 over 4 plus 2. That is 12 over 6, which is 2. So in this case, my average rate of change would be 2. Okay, that's what we do for that one. Okay, table's pretty straightforward. Graph is actually pretty easy too. So finding the average rate of change from a graph. Give us all this junk information that they're asking us to do. Use the graph to estimate the average rate of change of our industrial robot sales, blah, 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 then check your results algebraically. From 2005, so notice here, this is years since 2005. So 2005 starts off at 0. So 2015 is 10 years later, okay? So that means we're going to look at the y values, which are way up here. So notice that my y value at 10 is 240. So for this last one, I do my average rate of change. My y value is 240 at 10. My y value all the way over here is 120. Oops, I'll do that. This 120. And then I'm going to look at the difference in the years, of course, 10 minus 0. So I get 120 over 10, which equals 12. Okay, so my estimate, I actually figured out the average rate of change. So it says then use the graph to estimate it. So we're looking at this here. We can kind of see that the average rate of change, you can kind of guess it's going up. And actually, I would guess that is 12 anyway, because you can see if I were to draw a straight line up here and I look at the slope, what's the change in y? 120. What's the change in x? 10. So I would guess that the estimate is also 12. Oops. Let's see what the answer is, since I don't know. Hold on. Oh, of course, what a dummy. Thousands of robots. So I guess I should have read that. So even though the 12 is correct, it should have been 12,000 because this represents the number of thousands of robots. So that's okay. So interpret your results in the situation from that 2015. The average rate of change in industrial robots increased by 12. I think 1, 2, 3. I think this is what they're asking for. In this case, oh my goodness, increased by 12. Okay, so I'm not sure why that's, 12,000 robots. Oh my goodness. So I guess you have to be careful when you're answering these questions here. Okay, so anyway, so that's what we do to get that one. Even though we got all the numbers correct. You got another check, and I think that's your last one. So we are done with this section.